Alright, here goes a video on complex numbers and the number I. Now, you already know that the square root of 25 is 5. You already know that the square root of 8 is 2 root 2 after you break down the radical and simplify it. Today, you actually can take the square root of a negative number. The square root of a negative 9 is 3i. That's right. All you have to do is put an I at the end of it. There's the bell. Class is in session. So the square root of a negative 12, you still break down the negative 12, and you're still going to get your 2 root 3. But now it's going to be 2i root 3. The I comes right before your radical when you're simplifying. And that's because we have this imaginary number I squared is equal to a negative 1. We know that anything squared is positive, except for I. I is imaginary, and we're going to say that whenever we square I, we get a negative 1. Okay? That's a very important skill to have, because now we're going to start solving equations for x again, but you might have an imaginary number. So for example, to get rid of an x squared, like we've talked about in the past, we just square root both sides, and that'll cancel the x squared to become an x is equal to the square root of a negative 9 is plus or minus 3i. So just like the other day when we solved by square roots and when we got to x is equal to, we had to say plus or minus because the negative 3 squared is 9 and 3 squared is still 9. Well, I squared is a negative 1, so that's where this negative side comes from. So just remember your plus or minus, and remember all the rules of before are the same. But if it's a negative number, you can't forget the I. So this, we subtract 10. We get 2x squared is equal to a negative 8. Divide both sides by 2, and we get x squared is equal to a negative 4. Square root both sides, and we end up with x is equal to plus or minus 2i. And you're done. So why don't you try the last three? It's the same material from the previous video with solving for x using square roots. This time, just make sure if it's negative, you use I. Go try them. And let's see if you got what I got. This one you just had to divide by a negative 2, and then the square root of 12 is 2i root 3. Since it's solving for x, we have plus or minus 2i root 3, and you're done. Take the square root of both sides on this one, and you're going to get plus or minus 5i. For the square root of negative 25. And then you have to subtract the 2 to the right, so x is equal to a negative 2 plus or minus 5i. And this last one over here, the square root of a negative 12, again, is plus or minus 2i root 3, just like it was up here. But now since this is x plus 2, we have to subtract the 2, and you leave your answer as negative 2 plus or minus 2i root 3, and you are done. Okay? So that's solving. Now we need to talk about simplifying. We can add, subtract, multiply, and divide. We're going to do all three really quick. When you are adding or subtracting, it's just combining like terms. So 3 plus 4 is 7. And 2i plus a negative I is plus I. And you're done. All you have to do is add your integers or your real numbers and add your imaginary numbers, combine them, and you're done. Same with this one. 6 minus 4 is 2, and then you have 3i minus a negative, which turns into plus 2i, is going to give you plus 5i, and you're done. That's it. Combine like terms, be finished. When you get to multiplying, however, we have a little trick that's going to happen. Now, this is just distributing, so you're going to get 2i times 3, which is 6i. And then you're going to get 2i times 3i, which is 6i squared. Now, if you go back and think for a second, what did we say I squared was equal to? That's right, negative 1. So, this is technically negative 1. So, this is actually saying 6i plus 6 times a negative 1. So, that's 6i minus 6. Just so you know. Proper notation for complex numbers, the real number goes first and your imaginary goes second. So your final answer is negative 6 plus 6i. When you FOIL, it's the same as foiling. 2 times 4 is 8. 2 times I is a 2i. Negative 3i times 4 is a negative 12i. And a negative 3i times I is a negative 3i squared. Combine like terms in the middle. 2i minus 12i is a negative 10i. Then we have our 8. Now remember again, I squared is a negative 1. So this is negative 3 times a negative 1. So this is plus 3. Final answer, 11 minus 10i. Now you can go ahead and pause the video and FOIL 2 plus 3i with itself. Go. Did you get negative 5 plus 12i? Because all you had to do is FOIL this, and then you're going to end up with a positive 9i squared at the end, which is a negative 9. 4 minus 9 is a negative 5 plus 12i. You are done. One more thing to talk about, and that's division. And then I will do 1, you will do 1, and we will be done. So 6 divided by 1 minus I. To get rid of the denominator of 1 minus I, because you're not allowed to have an I in the denominator, just like you're not allowed to have a radical in the denominator, you must multiply the top and bottom by what is known as the conjugate. So we still have a 1 and an I. However, the sign is always opposite of what it is in the denominator. So this is 1 minus I. These are going to be 1 plus I. Now you just FOIL the top, or distribute the top in this case. So 6 times 1 is 6. 6 times I is 6i. Now the bottom, the purpose of the conjugate is to make the I go away. So I will show you that all you have to do is FOIL the bottom. So you get 1 times 1, which is 1. 1 times a positive I is a positive 1i. Negative I times 1 is a negative I. And negative I times I is a negative I squared. And that's why we do this, because a positive I and a negative I will cancel each other out. Anytime you multiply by a conjugate, the i's or the roots or the x's, whatever you're working with will cancel. Okay? Now you just have to simplify. Remember, I squared is a negative 1, so this is technically a negative 1. So once we finish this, we're just going to have 6 plus 6i all over 1 minus a negative 1 is 2. Last step. You should split these. This is like saying 6 halves plus, and then we have this, 6i over 2. The reason why you split them is so you can see that you can reduce them. So 6 over 2 is actually 3, and 6i over 2 is actually 3i. And now you are done. 3 plus 3i. So go ahead and pause, try the last one. This time you're actually going to have to FOIL. So you're going to be multiplying the top and bottom by 4 plus 2i. And see if you can handle the work. Go. And there you go. FOIL the top. You're going to have 8 plus 16i plus 6i squared, which this I squared is a negative, so that's technically a negative 6, which is why this turns into a 2 plus 16i. The bottom, you're going to have 16 minus 4i squared, which turns into a plus 4, so you have 20. Always separate them because then they can be reduced. 2 over 20 is 1/10. 16 over 20 is 4/5, so you have 1/10 plus 4i over 5. That's it. You're done with complex numbers. We will be applying this to the future solving and stuff like that as well, so make sure you know these skills. This is Longo, and I'm out. See you. Bye.